Hello, everyone. My name is Nalu Tripician, and I am a software engineer with Azure Cosmos DB here at Microsoft. Today, I'm going to be giving you guys a quick introduction to Cosmos DB and how to get started using dotnetaspire. As we all know, modern apps have complex data needs. Those can be combining data from multiple different data sources, such as events from different microservices or handling user input. It's also important that your database is able to change to your business requirements. That could cause a change in schema. Your database should be able to adapt without having any heavy changes to your application. And as your application scales, your database should be able to scale too, deliver consistent performance, ensuring that your database is not a bottleneck. If any of those sound like something that your application needs, then you might want to consider a NoSQL database, one of the many different data models that Azure Cosmos DB offers. NoSQL with Azure Cosmos DB is fast, flexible, and distributed. And it's enterprise ready for many different scenarios, from artificial intelligence to Internet of Things device telemetry. Some of our customers include the biggest retailers, gaming platforms, and financial institutions in the world, really showing that Cosmos DB is a super great option for any type of business. Some of the features that make Cosmos DB so great are its ability to scale. Cosmos DB offers infinite scale with zero downtime. Cosmos DB will scale horizontally by adding more physical partitions when your workload grows. This growth can either be coming from adding more data and needing additional partition to provision that data for, or by raising the request units, or RUs. RUs are Cosmos DB's measure of how much throughput a container can handle. You can have there are different provision throughput models, but essentially, if you need more throughput, all you have to do is raise the limit, and Cosmos DB will automatically, in the background, raise that limit with no downtime. As you scale, it's also important that you have consistent read and write performance. For point operations, it's consistent that even when you add more physical partitions, that your read and write performances are consistent. Cosmos DB will always know exactly where to route your request to, meaning that it can provide this consistent performance. Now, going back to RUs, for point reads for a 1 kilobyte doc, that will be about one request unit. Queries, on the other hand, might need a fan out across multiple physical partitions, which may impact which can impact your performance as you scale. However, through the SDK, you can tune these queries in order to mitigate this. So we talked about container scale, but Cosmos DB can also scale in a different way, globally. Cosmos DB easily allows you to add extra regions to your account with no data replication or sync management needed. All you have to do is go into the Azure portal, and with the click of a button, your Cosmos DB is now in a different region. You can add different regions as read regions for optimized read latency, or as read-write regions, which is super helpful for high availability scenarios. Cosmos DB also offers many other mission-critical services, such as security, analytics, Azure integrations, and much more. But right now, let's focus on scalability. Thinking about scalability can be daunting, and it's hard to anticipate your business needs in the future, but that's why Cosmos DB is built to scale with your business needs. One of the many ways to start small and scale up is with dotnetaspire, which we're going to go over later in the demo. The first way that I wanted to talk about, though, is with the local emulator. The local emulator is the easiest way to start up. You don't need an account, it's free and super easy to download, and just start testing some things out. The next way is with serverless. With serverless, you provision a real account, and this is great for dev or test workloads. Here, you only pay for the RUs that you use, rather than provisioning them up front. This is great for scenarios where you're developing during the week, but nothing's really going on the weekend. With serverless, however, there is no global distribution, and there are higher SLAs, but still a great way to start out. Another great way to start is with free provision throughput. With every account, with every subscription, you get one free account per subscription. This allows you to have the first 1,000 RUs and 25 gigabytes of data free for the lifetime of the account. This also does not limit on scale, and you can add as much data and scale globally as you need. This is a good way to allow for a low-cost startup. The final way is with auto-scale. With standard provisioning, there are two ways to start an account: with manual and auto-scale. With manual, you pick your throughput level, and that's it, until you decide to change it later in the portal. With auto-scale, what you can do is set a maximum RU threshold, and that way, Cosmos DB will automatically scale from 10% to 100% of that maximum. This is great for workloads with high variability, and the containers will automatically react without needing to change anything to be at the highest level, and go back down to the lowest when the traffic dies down. This allows you to have peaks and valleys. This is great for applications with peaks and valleys in your workload. It will react seamlessly with the traffic, and there's nothing that you have to configure apart from setting that maximum. Another great option is dynamic autoscale. With dynamic autoscale, each partition scales independently, where in traditional autoscale, like I just talked about, all the partitions scale up together in all the regions. Here, it's great because you only have to pay for the throughput that each individual partition uses. Now, we learned about some of the provision options and a little bit of an intro on Cosmos DB. But now you might be thinking, how do we get started? Well, there are various different data models with API access, but today we're going to be focusing on our NoSQL database offering and, of course, the .NET SDK. To add the .NET SDK to your project, just do .NET add package microsoft.azure.cosmos. Once you have the SDK installed, you'll be working through the logical resource model. That starts with the Cosmos client. This is the entryway to the account. With the Cosmos client, you're only going to use a single client for your entire application. This client is thread safe, it manages all the connection, and it keeps all the caches, like the address cache and the session token cache, and all other metadata wrapped up in a nice box. It's super smooth to use with no extra overhead. Once you have your Cosmos client, you can start connecting to your databases, which in turn hold your containers, and of course your containers hold your items. Now, there are two different connection modes that we have in Cosmos DB. There is gateway mode and direct mode. Gateway mode uses HTTPS to connect to a gateway node, which interacts with the backend. The backend is the physical partitions of the containers that you have. Direct mode, on the other hand, uses TCP to directly connect to the backend, skipping that extra backend op. This allows for lower latency. However, if you do have hundreds or thousands of partitions, this will open a lot of connections, so there are some trade-offs. However, we do recommend using direct mode for the lowest latency and best performance. With the use of Azure components, it's never been easier to quickly create an application using Cosmos DB. So that brings us to our demo. For our demo today, we're going to be looking at an application that is a dashboard managing Internet of Things devices. So let's first take a look quickly at our application right here. So as you can see, we have an Aspire application where we're adding Cosmos DB and we're adding our database. This is also going to be run using Docker containers. And we're also going to be using the emulator today, as it's the easiest way to start up and just show everyone how easy it is to develop with Cosmos DB and Aspire. So once we get this up and running, let's take a look at the dashboard. As you can see, we have our Cosmos resource, our API service, and our web front end. So let's take a look at this front end to see what's going on. You can see here that we have a few devices online already, but it's super easy to add another one, or even offline some of the devices. We can also delete these devices. Now, all this information is being stored in Cosmos DB. So let's take a quick look under the hood to see what's going on. So here inside of our application, we can see that we're creating a Cosmos client. Now, again, because our best practices include having a singleton client instance, this client is going to be using dependency injection to make sure that it's used throughout the app for everything that we need with Cosmos. Now, when we're setting up our Cosmos client, there are a few different Cosmos client options that we can have that will change the behavior of our application. The first of it, which is we can set our application name. So right now we have a name Cosmos DB, but we can name it anything we want if we want to add, let's say, demo to it. The next is we have custom serialization options. Now, there are a few built-in serialization options, such as having everything be a camel case, or just the default, which is passing everything new normally. But you can also pass in any custom serialization options that you want. Another really important thing that we should go over is Cosmos OpenTelemetry in distributed tracing. Now, OpenTelemetry and distributed tracing is the best way to help debug your applications. So it's always important that we turn those on. And one other thing that we can see is that we have that we can control the connection mode, and we can easily switch between direct mode, which is the default, and gateway mode. Now, if you might have noticed earlier that I didn't actually press the delete in our application, that's because there might be a little bit of a bug that we can take advantage of seeing the power of OpenTelemetry and distributed tracing, but to see how easy it is to debug. So first, let's try to delete an item. Nothing happens. So we should probably see what's going on. Going back to our Aspire dashboard, going into the traces, and we can see some of the calls that we have to Cosmos DB. Scrolling down, you can see these delete calls that are causing some errors. Let's take a quick deeper dive into it to see what's going on. So we see that we're having our delete item async call. We can see that we're using our OpenTelemetry. We can see that we're on gateway mode. We can see our machine ID, the type, and the status code. This is really important. So you can see that we have a 404 status code for the delete item async. We can also see our exception message, which we'll dive into really quick. So we can further see if there's anything that could help us debug this. So let's paste this in here and look in to see what's happening. You can see that we have our system history. You can see our response status code does not indicate success with our 404 error. And we also have our activity ID, which can be helpful for tracing further errors that might be occurring with this specific call. Now, since we have a 404, that might be pointing us to something. Like I talked about, we have these custom serialization options that we're using, which right now we're using camel case. However, if we look at our delete item call, here you can see that we're passing something in called the partition key. This is how Cosmos DB intelligently routes its request. Now, the important thing to know about partition keys is that it is case sensitive. So with our serialization options, chasing it to camel case might not be the best option. So let's go back here, change camel case to default. And let's also, in the meantime, change it to direct mode. This is going to allow us to use the best practices that we talked about earlier and getting the best performance for our application. Okay, great. Now that we have everything debugged, let's say that we want to move to a live account. Now, with live accounts, it's really important that we, with global distribution, that we specify exactly what regions that we want our account to use and when. To do that, we can use something called the application preferred regions. That's another option inside of the client, Cosmos client options. So if you go into our Cosmos client options, and we have application preferred regions, we can create a new list that contains all of the regions that we have in our account. So let's say that we have a region in East US, and we also want to expand to West US. With application preferred regions, we can specify this list, and the SDK will know exactly what regions to route to. And if there's a case of an outage in the East US region, then we'll go to the West US region. But so that we want to expand even more, we can just easily go back into the client and create new options. Let's say if we want to create a new region in Central US. Easy, right? Now let's look further down into the item calls that we were talking about earlier. Now, it is also something that you can do in Cosmos DB is update the request options for each request. So let's say that we want to limit the items per page that we have to, let's say, 10. That's super easy to do. And when we're doing our query to look up all of our items, we can just set the max item count to 10 inside of our request options. There are various different request options that you can do, like I said, to help with tuning queries, or even to help route specific requests to certain regions, and they're super easy to change. Now, that's about all I have for you today. So before we end, I want to leave you guys with some extra resources. This first resource is another way to create a Cosmos DB account for free. It lets you try for 30 days with no sign-up, subscription, or credit card needed. I've also included some documentation that goes into a bit more further detail on how to start developing using the .NET SDK, as well as a link to the best practices that I was talking about earlier, which includes some other resources. I also have included the link to the demo that we used today. I want to thank you everyone so much for joining and hope you have a great rest of your day with .NET Aspire. Thanks. Bye.